2.2 is about conditional statements. When you're taking the key concepts here, I kind of took these pictures because these are kind of important here. A conditional is an if-then statement. If I take notes, then I'll get an A. See what I did there? The hypothesis is the part P following the if. So look for the if. The hypothesis is I take notes. So that's my hypothesis. The conclusion is part Q, which follows the then. Then, my conclusion being I'll get an A. Okay, the key there is the hypothesis follows the if, and the conclusion follows the then. Okay, there's the key there. That's what we call a conditional statement. The converse of that is where you exchange Q and P. So in other words, that's if I get an A, then I take notes. Okay, if that's true, maybe that's not. We'll talk about that in a second. The inverse is when you negate both of them. If I don't take notes, then I won't get an A. Okay, that's the inverse. And the contrapositive, you flip it and then you negate it. So if I don't get an A, then I don't take notes. Something along those lines. Obviously with wording it might change a little bit, but you understand the concept there. Problem 1 is identifying hypothesis and conclusion. So if an animal is a robin, then the animal is a bird. Again, look for the if and the then. So our hypothesis is going to be an animal is a robin. Your conclusion then would be the animal is a bird. Problem 2 is writing a conditional. Vertical angles share a vertex. That's our statement. So how do I write that? Again, I need to put it in if-then form. If angles are vertical angles, again I abbreviate so I can make this faster. If angles are vertical angles, then, that's that key aspect here, then they share a vertex. Problem 3 is about finding the truth value of conditional statements. Is the conditional true or false? If false, find the counterexample. Okay, if true, you don't need to make a counterexample. It's true. But if it's false, you got to give a reason or a counterexample as to why it's false. So A is if a woman is Hungarian, then she is European. So if you pay attention in your history classes and that, you would know that Hungary is in Europe, so this is a true conditional. Part B says if a number is divisible by 3, then it is odd. Well, that's all it's saying is that if the number is divisible by 3, that number has to be an odd number. Well, that's definitely false. A counterexample to that would be 12, okay? Because 12 is definitely divisible by 3, and the answer is 4, so it's not an odd. Problem 4 says to write and find truth values of the statements. What are the converse, inverse, and contrapositives of the following? If the figure is a square, then it's a quadrilateral. Let's start with the converse of that statement. So the converse of that is we just take and we flip the two statements. So the converse is if it's a quadrilateral, then it's a square. Of course, part of the issue is understanding what the statement says. What it says is if it's a quadrilateral, then it's a square. Are there any other quadrilaterals that aren't squares? Of course, a rectangle would be a quadrilateral. Of course, there are other quadrilaterals. Quadrilateral is just a four-sided figure. So my answer here is false. A rectangle is a quadrilateral. The inverse of this statement, again, would be just being able to go ahead and flip them. So the inverse of my statement here if the figure is not a square, then it is not a quadrilateral. Answer to that then would be false. Again, for the same reasoning. A rectangle is a quadrilateral. Last but not least is the contrapositive. Again, that's where you flip the two statements and you negate them. So if I flip them and negate them, it would be, say, if, again, always start with the if, the figure is not a quadrilateral, then it is not a square. And that, of course, is true. Not a quadrilateral, can't be a square.